Hello and welcome to the second seminar in our series of BIM for building product manufacturers. Our objective for this webinar is to give you a brief overview of some of the steps required to prepare your 3D models for BIM users. We'll review ways a product manufacturer can share data with BIM consumers using data-rich content. And when you manufacture with BIM in mind, it allows you to get specified into BIM projects earlier and many times exclusively. So who is M2 and what do they do? Well, we are an Autodesk reseller and an EdgeCam reseller, as well as an authorized training center for both softwares. We have an extensive staff of technical consultants, software developers, and account representatives. You can see that we list our primary locations on the right-hand side of this slide, but we can service you anywhere within the United States. Who am I? I am Doug Roby, and I am your presenter today. I am the Director of Consulting Services at M2 Technologies. I have 20-plus years of design experience in the manufacturing sector and nearly another 20 in the consulting services industry. I consider myself a design process improvement expert, as I have helped design and refine a lot of companies' design processes to help improve their efficiency. I have expertise in both 2D and 3D design, data management, and design automation. I'm also a holder of a U.S. patent from my previous employment. So let's get started into preparing your design for BIM. As a quick review, what is BIM? BIM is a process that uses intelligent 3D models to give architects, engineers, and construction personnel the tools to efficiently plan, design, construct, and manage buildings and infrastructure. Why should you use BIM? First off, it brings new opportunities to a broader range of customers. Second, many times it's requested. A designer will have a requirement for BIM and then will request a BIM content model. And three, it's easier to have for simple coordination by having standard information in a standard format. It allows for that coordination between manufacturers and designers. BIM uses levels of development. So here's a slide in which we have several models in the levels of development. Which model do you think is the one we're going to concentrate on supplying? Some say it may be the model to the far right under the facilities management, where it's got all the detail. Everything is there that you need to know. Nothing is left on the table. Others might say all of them. It's all going to depend on what you actually need, so you need to be able to generate and supply each of the models. But really, it's most likely the yellow model, the construction model. At that phase of the building's life cycle, the construction professional is generally making decisions about specific products in specific sizes. Most likely their big concern is their size and spatial requirement. This particular level of development model gives us a detail that you need without overburdening you with excessive details. So you got to remember, architects and designers have been using BIM for many years and have developed their own content for the concept and design phases, and it typically doesn't match the manufacturer's specific model information you see on the right. So why should we, create that simplified model of a fully detailed model? Well, number one, it will increase performance. Reducing unnecessary and unneeded details will only help to increase the speed and also reduce model size. Because remember, buildings sometimes have thousands and tens of thousands of components to it. For easier adoption, by not overcomplicating your model, more people are likely to use it. If you keep it simple and only have the requirements that they need, yeah, they're going to grab it. If you have too much, they're probably not. And number three, the protection of your proprietary information. Let's face it, I don't know, intellectual property is important. You spend a lot of time, designing it, putting all that information and everything else into it. You just don't want to give it away and have anybody just, go ahead and build it again. So what are the requirements to produce BIM content? First of all, there's a geometry and data requirements. Things like shape, dimensions, description, weight, cost. Those are all pieces of the information that the end user is going to require. From a 3D modeling or an Autodesk Inventor concept, you might think of it as I properties. Intelligent connector points, places where your mechanical, electrical, and plumbing connections are all made on your model. It's just water, air, electrical, those things that where they get connected so that they can route those conduits and pipes and etc. Also, design for a purpose. Going back to that slide a couple of slides ago, you remember the chair. Each model had a specific purpose. So that means when you supply some BIM content model, you need to have the correct characteristics specified for the correct stage of the design process. Here's an infographic from Autodesk outlining the basic workflows for BIM content creation within Autodesk Inventor using 3D models. There are 3 basic workflows. The first is a non-configurable assembly or model. This is generally a static model with no changes or parameter-driven options. Here's your model, use it, thank you. A thing like maybe a large air handler with just basically the box outline so they know where it can fit in, its general shape. That might be the idea of a non-configurable. A configurable assembly would be one that uses parameters and options, many times driven by Inventor's built-in iLogic, to define the size, shape, and any extra features of a model. So let's say that air handler now has, 2, 3 filter units or so. So you can build that model and specify that, and then supply, each particular model to the consumer. And then we have BIM on demand. This is generally for parts that you're going to put up configurable models, and they are placed on Autodesk's Configurator 360 cloud-based tool, which will allow a consumer to just jump up online, configure their own model, and then download it in one of many formats. And this is all done on an as-needed basis. So getting your model ready for BIM consumers, right? Creating BIM-ready content. When you need to first off simplify the geometry. BIM consumers don't want high detail. Many of the stuff that we need is unnecessarily and doesn't fit. Internal components are generally the #1 piece, right? We don't need to let them know what we have inside. You accomplish creating BIM-ready content by removing intellectual property, by removing those internal components, as well as small features and/or voids, such as holes, right? When you do remove those, though, you need to remember to keep the information for your connection points. So what does this mean from an inventor standpoint? It means creating a shrink wrap model. It means removing fillets, chamfers, pockets, any unnecessary holes. Remove features. You can do this by removing features by the size or by the name. You could also create a substitute part that can be used to create that BIM-ready content, and then have the two of them. You have your full assembly, and then you have an alternative one, if you will. After you simplify your model, you go ahead and you author your model. Authoring means you add those connection points that we talked about, define the Omni class, define the populated properties, and define the orientation of the model. The MEP connections that we'll talk about, those are what you need to define where your water your fluid connections, your air connection, your electrical connections all get made. An Omni class is a classification that defines the type of product that you're supplying. Is it an air handler unit? Is it a window or door? Is it a plumbing fitting of some sort? Um, the properties that you might add maybe include model numbers, airflow, voltage, a link to your website where you can get further specifications on that particular model. And then the UCS or the orientation that we need to set up, that has to be changed based on the fact that the AEC industry uses Z as an up or a down, whereas the manufacturing industry uses Z as near or far. For the inventor models, to create BIM content, we go into our BIM content environment. Here, we can create our shrink wrap, we can add our MAP connectors, we can add the authoring information to the components, and this is where we actually export that component to a Revit compatible file format. So now let's go ahead, take a moment, and I'll bring up Inventor, and we'll create a BIM model using some of these simplifying and authoring tools. Okay, as you can see, I have opened up this blower unit in Inventor. It's a full-fledged assembly using frame generator, content center, sheet metal parts, standard parts, sub-assemblies, everything you can think of, a little bit of it all. So what we want to do, right, is to take this, and we want to simplify it. We're going to get rid of some of the fasteners, we're going to get rid of the detail on this, and make it much more BIM compatible, if you will. So I'm going to start by go ahead here, and I'm going to open up this particular assembly. And you can see that I've got fins and bosses and stuff that I just really don't need. So what I'm going to do is I'm going to actually go ahead and edit this AC motor here, and then go into it and get rid of the fins. And so I want to get rid of all these fins because we don't really need those in our BIM model. And then I also want to get rid of the bosses that we have here. So we're going to get rid of that particular array, if you will. So we'll suppress those features. So that just kind of simplifies it right down. And if we take a look around the back, the last thing that I think I'm going to get rid of is these slots. I don't really need those particular features as well within my mounting. I just need to know that there's a mounting surface there. So we're going to take that and get rid of it. So here's my assembly, pretty simplified down. And to make use of that, we're going to take it and simplify it one more step. And that is the case of creating a simplified part. So we're going to go ahead here and create this motor assembly, and we're going to leave it as a single body. And I'll hit OK, and boom, out comes a part. So here it is. It's a single part. It's really just a derived component, if you will. But to keep it from updating later on, I'm going to go ahead and break that link and then save it. All right, so we're going to get out of here. We come back to this, and you'll see now that we're back to here. But what I need to do is link the two of those together. So you can see this is two parts. We'll go ahead here. We're going to put this all back together to where it needs to be. So we'll edit that, and we'll unsuppress features here. Let's get into that. Unsuppress bosses, and then unsuppress those two. Bang. So we've put it back to its normal. And now we want to take that simplified part that we created and use it. And we do that through the level of detail. And we go in here, we're going to create a new substitute level of detail, and we're going to select the part. So it tells me I need to save it. And select the part. And that's the part that we want to use. So that's our simplified part. And we'll open that. And there we go. So now we went from a two-part assembly to a single part using this level of detail. So let's just call this simple motor, right? And then if we activate this, now we'll see that we have, you know, the fins and the details. And if we go back to here, you know, back and forth. All right, so life is good from that standpoint. We can change it back and forth. So again, let's just do one quick save, close it down. We'll be back into the assembly. Next thing we're going to do is a similar operation with the frame. Only in this case, we're going to go in here and we have a couple of options. We have the substitute derived assembly, which is similar to what we did when we did the replace part, but it doesn't get rid of all these extra details like the holes and the pockets. So what we want to do is we want to create a shrink wrap option of this. And when we do that, we get this dialog box that's going to, you know, tell me which level of detail to already use. But more importantly, it's going to now let me select parts and get rid of them. So you can see that I got rid of that extra piece that it probably doesn't need. I just really need the overall box. It also allows me to get rid of holes, pockets, fillets, and chamfers. So like in this particular case, I want to get rid of the holes in here or the pockets. So if I do a preview, you can see that it filled all those in. Now, and that's really what we want to do. We want to get rid of all those voids. The other one we're going to do is we're going to get rid of all the rounds or the fillets on the end. So that will get rid of this. Over here, you can see that we're going to get, you know, some names, if you will. So let's go ahead and call this simple frame. It'll be a standard part. And again, we'll kind of pull it all together without any seams, make it as simple as possible. And I'll hit OK. And there you go. We've got this nice, simple box frame, if you will, that we can go ahead and create. Let's go ahead and save that, and we'll close it, and we'll come back to our main assembly. Now, in our main assembly, we need to get those parts activated and usable so that when we go to pull those out. So the first thing we'll do is we'll update everything, refresh it. Then we'll go into our motor here. And what you're going to notice is under the representations, we now have that simple motor. So we'll go ahead here and activate that. And now you can see that, you know, it gets rid of all the extra details in it. We'll do the same thing for our frame down here. And we'll go to its representations. And we'll do the substitute level of detail, which brings us to there. So now, you know, we have two simplified models within this top level of assembly. The next thing we want to do is we now want to go back into the BIM environment and, you know, make the changes there, not, you know, kind of get rid of some of this stuff. So we'll go into BIM. Here's my BIM content on the Environments tab. And to start with, I'm going to go ahead and I'm going to add some connectors. So we have air coming out. We've got, if we rotate around a little bit, we've got air going in, and even further, we got some electrical power right here. So we'll go ahead and you know, add those connectors, if you will. Really simple. I can do it from up here on the toolbar, or I can do it from within the browser. So let's go ahead and add a duct connector. It's going to be circular. And we're going to go ahead and get that flange. We're going to change the direction because it's coming out. System type is going to be exhaust. And now we can go ahead and, you know, measure some specific loss, some coefficient loss, you name it. I'm going to leave it at none because I don't think we're going to get a whole lot. The connection type is going to be flanged. Flow configuration is preset. So we're going to do a 100 CFM, if you will. Oh. There we go. Cubic feet per minute. Flow direction is going to be out. And then down the bottom here, we're going to call it air exhaust. And that's our first connector. Let's go ahead here now. spin this thing around, and we'll do the same. Another duct connector, again circular. It's going to be on this point. It's going to go in, as you can see. It's going to be a supply. It is also going to be banded because it's going to put a pipe over the top. Flow direction is in, shape is round, and we'll call this one air supply. And then the final one that we will add will be our power. And you can see they get a couple of, conduit connectors over here. So we'll go ahead and make this an electrical connector. We'll define that geometry, and we're going to go balance power, description, power supply, and voltage is going to be 240, and single pole, load will be 30. Again, volt amps, classification, motor is a motor, so we want that. Power factor, power state, if you will, leading, lagging, so we're going to do leading, make sure all that information goes across, hit apply. So here you can see my connectors all in this particular setup, right? I can go ahead here and I can edit any of these if you want. Right. As you can see, they're all editable, which is a good thing. I can do that. You can also rename them. So I can call them common names, if you will, here, which is always a good thing in any design aspect. We'll make that go. There we go. And we'll take a look at it here. So now we have our connectors defined. Next step is to add the UCS. And because remember, we want to turn Z upright. So what I'm just going to do is I'm just going to grab a corner of this, if you will. And then I'm going to select the X and rotate it about 90 degrees. So when I look at the plan view, Y is going out, X is coming across left or right, and Z is coming up. And that'll be good. So that adds my UCS to this. I can position it anywhere I would like. The next step now is to do the building component, authoring it. This is going to add its classification, right? The orientation is going to be based on the view cube, or I can go on that UCS. I can now add the classification. You'll see that there is a bunch of them. So I just kind of typed in air, just so you can see all of them. It's actually pulling stairs as well as airs and hair. We'll come down here and we're just going to go ahead and find, let's see, we're going to find just a general air handling unit to utilize. And then we'll pull in some model properties. Right, so if you're looking for area centered gravity, that's always good. If you got to lift one of these things, how much is mass? So, we can kind of choose some of these, who built it, right? So project, we can add a manager information. We can go ahead and add part numbers, catalog links, you name it, physical stuff. So, I don't really care about the gravity. Maybe the volume that I want, right? My status, project, company, who built it, all that stuff can be added in. Right? These are pulled off the model. We can also add a description. Go ahead in here and add air handler and make it there. Model GS1700C. And 123.mtt.com. You send it to our website and we'll apply that. So we have now come to the point where we've finished simplifying and we've finished authoring. The only next step is to shrink it, do the final step of shrink wrapping. And you can see that that's right here. So let me go ahead and save this. and we'll do a shrink wrap to get rid of all the little bits and pieces to it. So it's this time we're going to start to remove parts by size. So here's my pick by size, and you'll see if I go in here and let's grab this little screw, all the screws of that size disappear. I'll make it a little larger. So now you can see in the lower corner we lost the washers and the nuts. If I come up to this one, it gets rid of all of those as well. The next step now would be to find out what parts that we want to include or exclude. So let's go ahead and do the exclude. I'm going to choose that. All these inner parts, we don't want those. So we're going to get rid of all of these. Get rid of that pulley and the belt. Let's go ahead and roll this around, get rid of the fan that's on the inside. And kind of leave just the shell parts. We click on the excluded, you'll see some others. I want to get that cover back. There we go. Back to the included. So now I really have, just that shell-based stuff that I want. It'll fill in holes and everything else. By going to the features, I already got rid of the pockets. Let's get rid of all the holes. We're not going to worry about any other settings, so just the holes are left. And over here, create, we're going to go ahead and call it Simple Floor Model. And we'll put that out there. And we'll put it into this particular workspace. And again, simplifying that out. So let's go ahead and now go ahead and hit OK and generate this. So inside here, we're building this nice simple model. Usually takes a minute for it to kind of calculate itself through. And there we go. So now we've got, this nice simple model that we can utilize. And then the final component to this is now to do the export building components. We'll select that. You can see that it gives us substitute. So let's call it Simplified. And then go ahead and hit the save button. Takes a second for it to run as it rebuilds its Revit families. And then it comes up and now asks you if you want to view the translation report. Now that we've done that, taken and exported that model, let's go ahead and look at another method of delivering a BIM model that you can define on the fly, or is otherwise known as a configurable model. This is a rules-based flexible model where we have options, adding and removing components, changing sizes, changing characteristics. It will be placed into a cloud-based environment where you can download that demand on content. And from that content, we can get both 2D and 3D information and deliverables from that. What does it mean for Inventor? It means it's a parameter-driven model. We're going to use our dimensions and we're going to drive those models. It's rules-based logic. So, if it's this size, it uses this parts, or if it has 4 of these, it needs 3 of those. The nice part about that is it's expandable. We can keep adding to that. When we put it to Configurator 360, we also have the ability of who can see what. So we can limit which customers have the option to see those parts and be able to download information. Let's go right into the demo. We'll go ahead and add a little feature to this model, get it up onto our Configurator 360, show you how that looks, and then download some of that output. What I have here is I've opened up an inventor model. It's a quarter turn ball valve. It's got multiple parts. It's an assembly that uses eye parts. It uses standard components. It uses some sheet metal. So it's a little bit of everything. It is parameter driven, and it does have some eye logic behind it. So we want to kind of show you how that works. So right off the bat, just using an eye part, I can change the component. And this is really what drives the configurableness of this. So you can see I just put in a small brass body. It doesn't fit. There's some other rules involved, but we do have the ability to actually change this around, if you will. So so all the pipe ends are that way. The ball, the same thing. Everything changes as it's all table-driven parts. We also have parameters up here where we can tell it that it has a handle, doesn't have a handle, the pipe end's unique, body material we just talked about, you can see that I just changed that. So again, it just becomes a configurable model. What we want to do here, though, just streamline everything, is we're going to jump over to show you some of the iLogic stuff here. And you'll see that, I have a form that's tied to a series of rules. So if I jump up onto this, you can look at my form, right? I can change it from a screw end to a socket weld, if you will. If I want to change it, to a smaller valve, back to a larger valve. You want to change the material, right? So it just kind of gives you that user interface, if you will. Makes it life easier. So what we're going to do here is we're actually going to add a new rule. And then get it ready to go to the configuration. So the first thing I want to do is I'm going to add a new level of detail, and we'll call this config 360. And we'll make that active. And we'll come back to our iLogic, right? You can see it's active. Come back here, and we're going to add a rule, and we'll call it handle. And it's going to open up this box where we can actually add our code, if you will. And it uses a simple VB-based coding from there. So it's all about logic. So I'm going to go ahead and put in my if-then statement. And what I want to do is I want to grab that user parameter for handle. And I'm just going to be able to capture it and drop it into place here. So you'll see that now if the handle is true, then to do something. So what we're going to do is we're going to capture the state of this handle. It is actually active. So is the component active? Yes, true. To go along with that, though, what we also want to do is add one of the constraints to it. And so I have this lock washer constraint that locks it down to the handle. So I'm going to capture that state as well. This is all if it's true. Now, if it's not true, then I want to, do something else. And really what we're going to do is we're just going to kind of reverse this stuff. So we'll just copy and paste it over to here. We'll make this false. And what we're going to do is we're going to set this to a different value. So I know that it's 188. All right, let's go ahead and start here and put code on there. Just give you a little comment to do that. We'll hit save, and then we'll close this down. Now we'll go ahead and we want to test that. So we can test that by going to our parameters, right? And if you remember right, we showed this a little before, but I have one called handle. If it's false, you can see that it shuts it off. If it's true, it turns it on. So there, I've just generated a quick if-then statement to give me that configuration or configurability. Let's tie that into our form now. So we'll go over here. We'll edit the form for this. And you can see this gives me the preview. Well, what I want to do is I want to take that parameter and I just want to add it to the form. So we'll go over here. We'll drag this in. We'll put it in. You'll see it says handle is true. Let's kind of reposition it up a little bit. Right. And I just want to edit it from a true and false to a checkbox. So if I have this checkbox now, if it's checked, Yeah, it's going to be, it's going to have a handle. If it's unchecked, it's not going to have a handle. Let's go ahead and hit OK. And then let's test that. Right? So we know we've already seen this change, pipe ends change, if you will. Let's go ahead and see what happens with the handle. Beautiful. On and off, on and off. Sounds awesome. All right, so we've added that rule now to our model. So let's go ahead and save it. And now let's turn around. We're going to upload it to our configuration 360. So two ways of doing that. One is to wrap it all up into a zip file and push it all up there, all the different versions and everything else. When you do that, that's usually the first type of move that you do. But as you move forward here, you can go ahead to our BIM content, and you can see that, this particular case, I already have some pipe connectors already added, so that stuff goes up top with it so that we can use that again in a BIM as a BIM model. But we got this upload to configurator. This upload model to configurator where your customers can see it. You basically just hit OK. It's going to ask you to save it. Yes. And then here it's going to tell you where to go. I'm actually going to do it because it takes a few minutes to go ahead here. But, I can select different versions, put this in. I can copy all the files, right? You can see all the files in the assemblies folders and its subfolders. So it kind of zips it up in the background, moves it all up. One of the neat parts about it is when you do go to do this, you can actually grab a drawing. And you'll see that, you'll see that I have this drawing here that reflects the valve so that we can, upload that as well. So after it's uploaded, it takes a few minutes to process. What does it look like? Well, let's go ahead here to my configurator site, and you can see here I have my valve in the catalog. So when I click on this, there we go, you'll see now that this valve generates up. Same thing that we saw in the in our inventor model. You can spin it and twist it and pan on it and zoom on it, right? So it's got all those little functionalities. But what's even better is we have the ability to configure it right here online. So you'll see that I have that form that I created in iLogic, and it's now available. So simple, right? You click on it, there goes the handle. Right? If we put it back on, you'll see the handle comes back. Right? We can change sizes. Takes a second to regenerate, if you will. Right? We want to put in a screw end. We even see that the thread, representation shows up there. Materials. So everything just kind of gets reflected and pulled across. All that work that you do in Inventor can now be pushed to the Configurator 360 and utilized. The next best part is, the outputs that we have. So here I've defined several 3D model types, step files, SATs, IGES, as well as an RFA file. So from our BIM content standpoint, we can download that RFA file. We also have the ability to do 2D output. So things like DXF and DW and PDF can be put on. So I just hit, if I select one of these, it generates the model in the background. This is on demand as I need it. You get a copy of it. It's like I say, it's building this model as we speak. And here you see, valve RFA. We can go ahead and just save that particular file, download it to where we need. We also have, like I say, the 2D version of it, which now is going to create a PDF file. We'll take and open that up real quick. And there's my drawing. These dimensions in here will actually update to reflect the model size as we go. So as you can see, using Inventor, we can configure our model. We use our environments to upload it to Configurator 360, and then we jump to Configurator 360 as our portal to download all our RFA files. So Not overly complicated. The hard part is, building the logic. The rest of it is easy. We have the tools for you. So there, I've actually, created that model and downloaded that information. So why should you get involved? First of all, it's a win-win for everybody. It's a win for the building product manufacturer, and it's a win for the BIM consumer. With BIM becoming a mandate in many countries, and that number continuing to grow every year, the requirements for us to supply that content will also continue to grow. Because we have to remember, as a building designer or an architect, they want to spend their time building that model and designing that model. They don't want to create the content that goes in it. They just want to consume it. So it's your responsibility as a product manufacturer to embrace this process and work with it and not be the hindrance behind it. Being that adopter. This efficiency is created by the building manufacturer creating good content from the word go. So, why now? Well, why not be a market leader? Why not get ahead of everybody else, right? Get ahead of that national and global mandate. And it positions you as a contributor to this process. People get to know you as that contributor. It allows you to have a better marketing tool. Say, hey, I can contribute to the BIM process. And it shows that designers that you care about building a better world. So how can we help? How can M2 help, right? We're a consultant that can manage and ensure that your content is properly formatted and globally available to the design and construction industry. That's the key. We have that. We can help where you design a cheaper and better sustainability product, so that instead of the building designer going to subcontractor and letting him, bid out the parts, you're already spec'd in ahead of time. This gives you exclusivity. This gives you the in up front, and they don't go and look anywhere else, right? M2 can help you, create that process and ensure that it's designed into the system up front and keeps that secondary user away. So, in short, while BIM is transforming the way the world designs, constructs, and operates buildings and infrastructure, by partnering with the leading building product manufacturers and a global leader in BIM consulting, the M2 Technologies team and their sister company Microdesk will transform how the design and construction market integrates building product manufacturers' information and how project teams purchase BIM components. We're confident that by working with existing product manufacturers, large design firms, large construction firms, and large owners, we can prove this out and have an extremely powerful story, allowing more manufacturers to expand into the world of BIM content creation and increasing their presence in early phases of design and construction projects. That's really what it boils down to. So, if you need more information, you can call our phone number there, look us up on the web. You can email us at support or info@m2t.com. We are here to help you. You can also connect with any one of our social media accounts and see the work that we're doing.